All right, good day, everyone. Welcome to this class once again. So, in the last class, we looked at indices and we looked at the laws of indices, and we were able to solve some questions on indices where we were able to apply the laws of indices. And we also looked at equations with powers. But today, we'll be looking at logarithm. But before we start up on that, just as a refresher from the last class, this is a tricky question from WAEC. Have 881 raised to the power of 0.2, sorry, 0.25 over 32 raised to the power of 0.2. All right, how do you solve something like this? How do you solve it without using mathematical tables or calculator? All right, now you must understand that 0.25 is equivalent to 1 over 4. How do we know this? Because we know that 0.25 is equal to 25 over 100. Simplifying to the lowest term would give you 1 over 4. So that's how that is possible. And we also know that 32, 0.2 is equivalent to 0.2 is equivalent to 2 over 10, which is equivalent to 5, sorry, which is equivalent to 1 over 5. So this is equivalent to 32 raised to the power of 1 over 5. Okay, now solving separately, you know that this is equivalent to, by our fractional power law, we're going to have 81 root of 4 raised to the power of 1 and 32 here, the root of 5 raised to the power of 1. This would give us 3 all over 2. With that, you have your answer. Okay, so that's basically what we did in the last class. So that was just a refresher. So let's look at logarithm. Usually, we've heard that logarithm goes hand in hand with indices. Hand in hand with indices. So what's really the relationship between indices and logarithm? What's the relationship between indices and logarithm? Now remember that when we write an expression like this, what it means is that the number 3 is the base and 81 is the power. Okay, we say that 81 is the fourth power of 3. Okay, now to also go in the other direction, we can say that 4 is the logarithm of 81 to the base 3. So the relationship, that means this is transforming this in the form of a logarithm would give us that um, 4 is equal to log 81 base 3. Okay, so the general rule for the relationship between between indices and logarithm is that if we have something like b raised to the power of x is equal to n, then we have that x is equal to log n base b. All right, log n base b. Observe the relationship between indices and logarithm. And then, so what it means is that if I give you 100, or rather 10 raised to the power of 2, which we know is 100, we know that writing it in the form of a logarithm would give us that. Let me give you some seconds to do this. Okay, check whether you're right. It would give us that 2 is equal to log 100 base 10. So that's the relationship between indices and logarithm. Okay, let's look at the laws of logarithm. Let's look at the laws of logarithm. Just like we have the laws of indices, we have laws guiding logarithm. Okay, now remember that when we're treating indices, our first law of indices gave us that. Okay, let me do this. We have indices, and then we have logarithm. Okay, our first law of indices gave us something like this, that a raised to the power of n times a raised to the power of n will give us a raised to the power n plus m. Alright, now in logarithm, this is what is applicable. Log xy log xy is equal to log log xy base a is equal to log x base a plus log y base a. Take note of that. Log x base a is equal to log y base a. Okay, now remember also that we had under the law of indices that a raised to the power of n divided by a raised to the power of m give us a raised to the power of n minus m. Now for indices, we have that log x divided by y base a would give us log x base a minus log y base a. Okay, all right. Finally, remember that under the laws of indices, we have that a raised to the power of n raised to the power of m is equal to a raised to the power of nm. Well, for logarithm, we have that log x raised to the power of n base a is equal to n log x base a. All right, take note of this. Take note of this, and because we will apply them in solving questions. Okay, all right, so how do we apply this? Let's solve some questions and see how we can use the laws of logarithm to solve. All right, so you're given something like you're given simple application such as this. You're asked to simplify if you're asked to simplify log 30 base 6. Now you must understand that 30 as a number has multiples, or rather has factors. So we know that log 30 base 6 is equivalent to saying log 6 times 5, since we know that they are both factors of 30. And according to our laws of indices, when there is multiplication, it's equivalent to having individual log of the factors. That's log 6 base 6 plus log 5 base 6. So doing this, we just applied the first law of logarithm. Okay, now how about something like this? Now you could be given something like log 100 divided by 3 base 4. According to our laws of logarithm, we know that this is equivalent to log 100 base 4 minus log 3 base 4. We've simplified it. Alright, now there are some other things I have to say that you must take note of under the laws of logarithm. Now, under the laws of logarithm, you must also note that the log of any logarithm to its base is 1. So you have something like log b base b, you're going to have 1. Of course, if I have log 10 base 10, the answer is going to be 1. So you must take note of this. And then you must also take note that the log of 1 to any base is equal to 0. The log of 1 to any base is equal to 0. That means if I have log, if I have log 1 is 10, I must have 0. And then log 1 base y will still give me 0. So the log of 1 to any base is 0. Alright, let's look at something very important in logarithm. Okay, simplify log 1000 base 10. Okay, you must remember that 1000 is equivalent to 10 raised to the power 3. So this is log 10 raised to the power of 3 base 10. Now, according to our third law of logarithm, when you have something like this, it's equivalent to that power will come and multiply the log of 10 is 10. This is the third law of logarithm. Now, you must also remember that the log of any number to its base is 1. So we're having log 10 base 10. So this is 3 times 1. So this is our final answer is going to be 3. Okay, now if that has been sorted out, let's look at another question. Okay, simplify without using mathematical tables. Simplify without using mathematical tables. Simplify without using mathematical tables. Log 15 over 8 base 10 minus 1 over 2 log 25 over 81 base 10 plus log 2400 over 81 base 10. Okay, to evaluate this is what we're going to have. Now you must remember that this is equivalent to having log 15 over 8 base 10 minus. Now for this, according to the law of indices, this is log, rather sorry, this is log 25 over 81 then raised to the power of half, then plus log 2481. Okay, so we have log 15 over 8 is 10 minus. Now, whenever you see anything raised to the power of half, you know that they're asking you to find the square root. 4 raised to the power of half simply means square root of 4, so which is 2. Okay, so 25 raised to the power of half will give us 5 over 81 raised to the power of half, that's square root of 81, 3 base 10, or rather, sorry, square root of 81 is 9 base 10 plus log 2400 over 8. Okay, you must remember the laws of logarithm. They all have the same base. Now, because we know that they have the same base, we combine them. So now, because these two are subtracting, the numbers we divide, we have divided by 5 over 9 times 2400 over 81. Okay, this is equivalent to log 15 over 8 times 9 over 5 times 2400 over 81. Alright, so if we divide through, 5 goes here, would give us 1, 5 goes here, would give us 3, 9 goes here 1, 9 goes here 9, 3 goes here 1, 3 goes here 3, 8 goes here 1. Remember, this is base 10. 8 goes here, this is 300. 3 goes here 1, 3 goes here 100. So in the long run, we are having log 100 base 10. And we know that 100 is same as 10 raised to the power 2. So we have base 10. So if this is the case, we're going to have, according to the laws of logarithm, we have 2 log 10 base 10. So I'm going to have 2 times, because the log of any number to the same base is 1. So I'll have 2 times 1, which will give me 2. So that gives us the answer. Alright, it's time to do something very important. Now, part of what WAEC will test you in is what we call substitution in logarithm. Substitution in logarithm. Okay, so some logarithmic problems involve substituting for a given log value. So what it means is that when you're given such a question, you are limited to solving that problem by simplifying to get exactly the log value or the multiples of that log value. A good example, given that log 2 base 10 is equal to 0.3010, and log 3 base 10 is equal to 0.4771. Solve without using table the value of a value of log 6 base 10, b log 5 base 10, and then c log 180 base 10. Okay, I'm going to add a d so that we could just use it to treat all of the kind of problems you will be expected to meet. Log cube root of 0.03. Okay, now you observe that in this question, you've been given a particular value. You've given the value of log 2 and you've been given the value of log 3. And you are not expected to use a table, and you're not expected to use a table to find this. So let's start with the first one. The first one says solve log 6 base 10. So because we've been given log 2 and log 3, I should ask myself, is there anything about 6 that has to do with 2 and 3? Yes, there is. We know that 6 as a number, we could obtain the number 6 from 2 times 3. So this would give us log 2 times 3 base 10. And according to the law of logarithm, this is same as log 2 base 10 plus log 3 base 10. See how simple it is now? So we've already been given the value of log 2 as 0.3010, and we've already been given the value of log 3 as 0.4771. So summing up everything would give us 0.7781. I want to believe that was clear enough. Okay, now for the B question. The B question, you were given log 5 base 10. Log 5 base 10. What is it about 5 that I can relate to either log 2 or log 3 or both. Now I know that log 5 is equal to log 10 over 2. So for me to get 5, I will do 10 over 2. Remember, to the base 10. So I will have, according to the law of logarithm, this would be log 10 base 10 minus log 2 base 10. And of course, this is equal to log 10 base 10. Remember, the log of any number to the same base, to its base, is 1. This is 1 minus, I've already been given log 2, which is 0.3010. Okay, so 1 minus 0.3010 would give me 0.6990. Okay, now coming over to the next question. Mind you, we are still working with the same value. For the C question, I've been given log 180 base 10. What is it about 180 that has anything to do with log 2 and log 3? So I know that I can decide to start finding the factors of 180. One of the easy ways to do this is to do this, which you were taught in the primary school. 2 divide 180, 18 is 9, 0. 2 goes here, 45. 3 goes here, 15. 3 goes here, 5. 5 goes here, 1. Okay, so you know that you have, we're looking for 2 and 3, so we know that we have 2 times 5, which is 10. So we could have something like 9 times 2 times 3. So I would use I will use 9 times 2 times 3. Okay, so I know that this is equivalent to log 9 times 2 times 3 is 10. So now, which is equivalent to log 9 base 10 plus log 2 base 10 plus log 3 base 10. Now remember that 9 is the same as 3 raised to the power of 2. So this is log 3 raised to the power of 2 base 10 plus log 2 base 10 plus log 3 base 10. So for this, I have 2 log 3 base 10 plus log 2 base 10 plus log 3 base 10. This would give me 2 times, remember that I've already been given the value of log 3, which is 0.4771, plus the value of log 2, which is 0.3010, the value of log 3, which is 0.4771. Everything, of course, would give me 2.2552, and that solves my problem. Okay, I'm sure that was clear enough. Now we're having a more, something is the next is looking more complex. So we have log, the D question, we're gonna have to find log cube root of 0.03. Now it is not really as complex as it seems. It's something you can do. Now you must understand that this is the same as log 0.03 raised to the power of 1 over 3. Okay, if this is the case, I have that according to the law of logarithm, 1 over 3 log 0.03, and of course this means 1 over 3 log 3 over 100. 0.03 is the same as 3 over 100. Remember that all of this is to the base 10, base 10, base 10, base 10. Okay, so now to continue my solution, I have 1 over 3 times. Now remember the law of logarithm, when we are having a division and we split, we will subtract. So we have log 3 base 10 minus log 100 base 10. So I'm going to have 1 over 3 bracket log 3 base 10 is 0. I've already been given log 3 base 10 as 0.4771 minus, of course, log 100 base 10 is the same as log 10 raised to power 2 base 10. Of course, this is 1 over 3 bracket 0.4771 minus 2 log 10 base 10. So now I'm going to have 1 over 3 0.4771 minus 2 because log 10 base 10 is 1. So of course everything, when I multiply out everything, I would have 1 over 3 times minus 1.5229, which will eventually give me minus 0.5076. So that's it. It's really not as difficult as it seems. It's something we can all do. Okay, let's look at logarithmic equations. Let's look at logarithmic equations. All right. Okay, so this is about questions in logarithms that involve equations. These equations could be linear equations, it could be quadratic equations, it could be, quadratic equations that, of course, you could factorize. We're looking at quadratic equations in some of our upcoming classes. And okay, let's solve something like this. Without using tables, find the values of x in the expression. Without using tables, find the value of x in the expression. All right, the expression is log x plus 8 is 10 minus log x minus 1 is 10 equal to 1. All right, so how do I solve solution? Now we know that this is equivalent to, I have to convert everything to be in the form of logarithm. So this is log x plus 8 is 10 minus log x minus 1 is 10 Now I must change this one. What can I do to 1 to make it to be in the form of log? Since this is in base 10, there's only one thing that could happen for this to be 1. So if it is the log of a number to its base, and since it's already in base 10, this is going to be log 10 base 10. So I'm substituting 1 with log 10 base 10. Alright, so let's continue solving. Now, according to the first law of logarithm, um, if we must combine, since they are in the same base, we're going to have log. Now remember that law states that, that first law states that log the second law, m minus n base 10 is the same thing as log m over n base 10. So if this is the case, then this is going to be log x plus 8 over x minus 1 base 10 equals log 10 base 10. Now, if we equate terms, we know that log 10 will cancel out log 10. So this is going to have x plus 8 over x minus 1 giving us 10. Cross multiplying will give us x plus 8 equals 10 times x minus 1. Of course, x plus 8 will be 10x minus 10. And that being the case, we would have collecting like terms would give us that 8 plus 10 equals 10x minus x. So we're going to have 18 is equal to 9x. Dividing both sides by 9 would give us that x is 2. So that's really not as difficult as you probably thought it was going to be, right? Okay, we just do one more on this and then I'll leave you with an assignment. Okay. Um, all right, let's take a look at this question. If log 2x minus 4 is equal to 1 plus log x plus 2, sorry, if log 2x minus 4 is equal to 1 plus log x plus 2 is 10, find x. Okay, to find x, remember we're already familiar with questions like this. So to find x, you remember that we will still let's collect like terms here. We have log 2x minus 4 base 10 minus log x plus 2 base 10 equal to 1. So we have log 2x minus 4 base 10 minus log x plus 2 base 10 is equivalent to we convert the 1 to log 10 base 10. Log 10 base 10 will give us 1. Now, according to the second law of logarithm, remember that log m base y minus log n base y is equivalent to log m over n base y. So if you remember that, you will now know that this is going to be log 2x minus 4 over x plus 2 equal to log 10 base 10. Okay, we cancel out the log, then we'll have that 2x minus 4 over x plus 2 is equal to 10. Collecting like terms, cross multiplying will give us that 2x minus 4 is equal to 10 times x plus 2. We have 2x minus 4 equal to 10x plus 20. So we're going to have minus 4 minus 20. Collecting like terms will give us 10x minus 2x. We have minus 24 equals 8x. If we divide both sides by 8, we would have that x is minus 3. And so as you can see, it's not really that much of a big deal. Part of the things remaining for us to do in logarithm, of course, is the use of logarithm table, but that will be handled in another class. I will be leaving you with this assignment. Try it on your own, and I'm sure you can solve them without having any issues. Okay, so 3 significant figures. To 3 significant figures, given that log 7 base 10 is equal to 0. And log 8 base 10 is equal to 0.903. Find log 6 whole number 1 over 8 base 10. B, log 1.25 base 10. Secondly, if log 3x minus 1 base 10 minus log 2 base 10 is equal to 3, find the value of x. Okay, I'm sure by now we can solve questions like this. Please, once you're done with the assignment, submit at the comment section. And if you have any questions on what we've learned so far, please kindly drop your comments and questions on the comment section, and we will be very glad to attend to you. Thank you very much for your time. Have a lovely day.